Event occur in m different ways, following which another event can occur in n different ways, then the total number of occurrence of the events is given by m into n. So whenever the repetition is allowed, the number of possible of 4-letter words with this rows is 256 words can be formed. The arrangement of n objects in a circle is called as a circular permutation. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session I am going to discuss regarding the simple concept, the basics of permutations and combinations. So permutations and combination, that is the selection of n things and the arrangement of n things taken all at a time. Now here, before going to the exact definition of permutation and the problems as well as the combination and the problem, let us know regarding the fundamental principle of counting. Let us discuss regarding the fundamental principle of counting. What is this fundamental principle of counting says? Now let us consider the following problem. Mohan has 3 pants and 2 shirts. Mohan has how many pants? He has 3 pants and 2 shirts. He has 3 pants and 2 shirts. So how many different pairs of pant and a shirt can he dress up with? So with these 3 pants and 2 shirts, how many different pairs of pant and shirts, how many different types of pairs he can dress up with these 3 pants and 2 shirts? So there are 3 ways in which a pant can be chosen, because there are 3 pants available. Similarly, how many shirts are there? There are 2 shirts that can be selected in 2 ways, can be chosen in 2 ways for every choice of a pant. So therefore, there are 2 choices of a shirt. Therefore, there are 3 into 2, that means 6 pairs of pant and 3 into 2, 6 pairs of pant and shirt he can wear. So listen to me. How many pants? Suppose P1, P2 and P3 pants are there. Now for the first pant he can take the shirt S1 and S2. Similarly for the pant 2 he can take S1 and S2. Similarly for the third pant he can take S1 and S2. So how he is going to select for pant number 1 and shirt 1, pant number 1 and shirt 2, P1, S1, P2, S2. So that is P1, S1, P2, S2. Similarly, second pant number 2, P2, S1, P2, S1 and P2, S2. Similarly, pant 3 and shirt 1, that is P3, S1 and P3, S2. So totally 1, 2, 3, 4, 5, 6 types. 6 ways he is going to dress up with this 3 pants and 2 shirts. So therefore, this is a best example for a fundamental principle of counting. Fundamental principle of counting. Now let me explain the definition. Now what is the fundamental principle of counting? If an event can occur in different ways, if any event can occur in different ways, following which another event can occur in n different ways. Suppose if an event occur in m different ways, following which another event can occur in n different ways, then the total number of occurrence of the events is given by m into n. So if an event occur in n different ways, following which another event can occur in n different ways, following which a third event can also occur in p different ways, then the total number of occurrence of the events is given by m into n into p. So if there are 2 events, it is m into n. If there are 3 events, m into n into p. This is called the fundamental principle of counting in permutations and combinations. Okay. Now let us take a small example. Let us take an example. Find the number of 4 letters. Let us come to an example. Find the number of 4-letter words. How many letter words? 4-letter words with or without meaning, which can be formed out of the letter of the word rose, where the repetition of the letter is not allotted, is not allowed, repetition is not allowed. So how many? Find the 4-letter words, 4-letter words. So first, second, third, 4-letter words with or without meaning, which can be formed out of the letters of the word rose, that is R-O-S-E, with this, then where the repetition of the letter is not allowed. Now, let us come to the solution. How many letters are there? There are 4 letters. So, the first place can be filled by 4 different ways of any one of the letters, like the first place can be filled by R, O, S or E. So, once if the first letter is filled with R, then if the first letter is filled by R, again the first letter is filled by O, again the first letter is filled by S, again the first letter is filled by E. Then what is left over is, if the first letter is filled, then the second place can be filled by the remaining 3 letters. Say for example, if this first letter is filled by R, then the second letter is filled by the remaining these 3 letters. So, the second place can be filled by any one of the remaining 3 letters in 3 different ways. So, the first letter can be filled in 4 ways and the second letter can be filled in 3 different ways, and the third place can be filled in 2 different ways. Once if you take any one of these letter, and the remaining 2 places can be filled by the remaining 2 letters. So, in 2 ways. So, the third place can be filled in 2 different ways and the fourth place can be filled in 1 way. So, therefore, the number of ways in which the 4 places can be filled in 4 into 3 into 2 into 1, 4 into 3 into 2 into 1. So, that is 4 is a 12, 12 2 are 24. So, we can fill in 24 ways. Hence, the required number of words is 24. See here, thus the number of ways in which the 4 places can be filled by the multiplication principle, that is fundamental principle of counting. We can use multiplication principle of counting. 4 into 3 into 2 into 1, that is equal to 24. Hence, the required number of words is 24. That's it. This is very simple example. So, here, what is the problem? The word rose is arranged. Find the number of 4-letter words with or without meaning. There may be a meaning or without meaning, which can be formed out of the letters of the word rose, where the repetition of the letter is not allowed. The first place can be filled in 4 different ways of the letters, any one of these letters R, O, S, E. Once if you fill one place using any one of these, the remaining 3 letters will be there. So, the remaining letters can be filled by the 3 ways, remaining 3 letters. So, the second place can be filled by any one of the remaining 3 different ways. And similarly, the third place can be filled in 2 different ways and the fourth place can be filled in 1 way. So, therefore, according to fundamental principle, the number of ways in which 4 places can be filled is 4 into 3 into 2 into 1, that is equal to 24. Okay. Now let us come to the next. If the repetition of the letters was allowed, suppose if you allow the repetition, in the previous problem the repetition is not allowed. Suppose in case if you allow the repetition, in how many words can be formed for the same word? So, one can easily understand that out of these 4 vacant places, 4 can be filled in succession in 4 different places. See here, these 4 can be filled in 4 different ways. So, first can be filled in 4 ways, second word also 4 ways, and the third, fourth, all the places, first place, second, third, fourth places can be filled by 4 different ways. So, 4 different ways. Hence, the required number of words are 4 into 4 into 4 into 4, that is nothing but 256. Suppose if the repetition is allowed, the number of ways in which the 4 different ways of the 4 different ways of the letter rose can be filled in 256 ways. So this can be filled in 2. So, whenever the repetition is allowed, the number of possible of 4-letter words with this rose is 256 words can be formed. That is the difference with or without repetition. So, with repetition 256, without repetition it is just 24 words, right? That is it. Now, let us come to the next example. How many 2-digit even numbers can be formed from the digit 1, 2, 3, 4, 5 if the digits can be repeated? With repetition. So, if the repetition is allowed, how many 2-digit even number? So, here what is the question? How many 2-digit even number can be formed from the digits 1, 2, 3, 4 and 5 if the digits can be repeated? Now, let us see how many even numbers are here. So, there are only 2 even numbers, 2 and 4 are the even numbers, remaining are the odd numbers. So, with the help of these 2 even numbers, we are going to construct 2-digit numbers. Now, so we start in the unit place because the option for this place are 2 and 4 because only 2 even numbers are there. So, the unit place can be filled either by 2 or 4. So, in 2 ways. So, you can fill the unit place by 2 or by 4 in 2 ways. Next, the tens places can be filled by any one of the 5 digits in 5 different ways. Any one of the 5 digits in 5 different ways as the digit can be repeated. Since there is a repetition, the 10th place can be filled by any one of the 5 digits in 5 different ways as the repetition is allowed. So, therefore, by the multiplicative principle, the required number of 2-digit even integers is 2 into 5, that is equal to 10. That is it. So, the unit place here, the first place, the unit place can be filled using any one of these 2 even numbers 2 and 4. This can be done only in 2 ways. The remaining, that is the 10th place, this place, unit and 10th place can be filled from any of the 5 digits in 5 different ways as the digits can be repeated. As the digits are repeated, we can fill in 5 different ways. So, therefore, the multiplicative theorem, according to multiplicative theorem, the required number of digits of even numbers, the required 2-digit even numbers is 2 into 5, that is equal to 10 with 1, 2, 3, 4 and 5 whenever the repetition is allowed. That is it. This is known as the fundamental theorem of counting, that is multiplicative theorem. Now, let us come to the important definition, that is the permutation. What is a permutation? A permutation is an arrangement in a definite order of a number of objects taken some or all at a time. So, a permutation is nothing but an arrangement. Arrangement of n different things taken all at a time is called a permutation. Permutation is called an arrangement, just arrangement of elements in a particular order. That is, so a permutation is an arrangement in a definite order of a number of objects taken some or all at the time. So, usually the permutation is denoted as, so the permutation of n different things taken or at a time is denoted as NPR. This is called the permutation. Now, the permutation of n different things taking or at a time is denoted as NPR. So, here NPR is nothing but the formula to find the permutation is factorial n divided by factorial n minus r. This later on we are going to discuss regarding the factorial notation of n and n minus r. So, in general, the permutation is nothing but arrangement of n different things taken or at a time. So, the arrangement of n different things taken or at a time is denoted as NPR is given by n factorial divided by n minus r factorial. Now, let us come to the theorem permutation when all the objects are distinct. So, permutation of all the objects are distinct, that is the representation, the number of permutation of n different things taken or at a time where 0 less than or equal to n and the object do not repeat is n into n minus 1 into n minus 2 etc. n minus r plus 1, which is denoted as NPR. This is the representation. Permutation when all the objects are distinct, so is denoted as n into n minus 1, n minus 2 etc. n minus r plus 1, which is denoted as NPR. So, therefore, the formula we are going to use for this is factorial n divided by factorial n minus r. That is it. Okay. So, here the number of permutations of n different objects taken r at a time where r is in between 0 and n, and the objects do not repeat is n into n minus 1, n minus 2, etc., n minus r plus 1, which is denoted as NPR and is given by NPR is equal to factorial n divided by factorial n minus r. Now let us come to the factorial notation. Let me explain before going to the problems on permutation. Let us know regarding the factorial notation. Now, what is our notation of n factorial? This is called n factorial. So, n factorial can be represented like this, or we can also write like this, factorial of n. So, the factorial of n is nothing but n factorial repeats the product of first n natural numbers, that is 1 into 2 into 3, etc., n minus 1 into n is denoted as n factorial. So, the notation n factorial repeats the product of first n natural numbers, that is the product of 1 into 2 into 3 into, etc., n minus 1 into n is denoted as n factorial, which is read it as symbol as n factorial. Thus, 1 into 2 into 3 into 4, etc., n into n minus 1, n minus 1 into n is denoted as n factorial. See, the factorial of 1 is 1 factorial, 1 into 2 can also be written as 2 factorial, 1 into 2 into 3 is nothing but factorial 3, 1 into 2 into 3 into 4 is nothing but factorial 4, and so on. Similarly, the factorial of 5 can also be written as 5 factorial, or we can also write like this. This is nothing but 5 into 4 into 3 into 2 into 1. This is how we are going to write the factorial of 5. So, since we define 0 factorial as 1, the factorial of 0 is equal to 1, and also we can write the factorial of 5 as 5 into 4 factorial, where 4 factorial is nothing but 4 into 3 factorial, or that can also be written as 5 into 4 into 3 into 2 factorial. So, this can also be written as 5 into 4 into 3 into 2 into 1 factorial. So, there are different ways to express this 5 factorial. 5 factorial can be written as 5 into 4 into 3 into 2 into 1. So, otherwise this 4 into 3 into 2 into 1 can be written as 4 factorial, 5 into 4 factorial, or again 3 into 2 into 1 can also be written as 3 factorial, 5 into 4 into 3 factorial, etc., and last is 1 factorial. So, clearly from this we can see for a natural number n factorial is equal to n into n minus 1 into n minus 2 into n minus 3, etc. So, this provided if n is greater than or equal to 2, n is greater than 2 or n is greater than 3. For this, if n is greater than 2, then it is n into n minus 1 into n minus 2. If n is greater than or equal to 3, then n into n minus 1 into n minus 2 into n minus 3, and so on, right. Now, let us take an example based on this. So, let us find out the value of 7 factorial minus 5 factorial. Now, what is 5 factorial? 5 factorial is nothing but 1 into 2 into 3 into 4 into 5. 5 4s are 20, 20 into 3 is 60, 60 into 2 is 120 into 1 is 120. Or you can also represent like this. 5 factorial is 5 into 4 into 3 into 2 into 1. 5 4s are 20, 20 into 3 60 into 2 is 120, right, 120. Similarly, 7 factorial, factorial of 7 can also be written as 1 into 2 into 3 into 4 into 5 into 6 into 7, that is equal to 5040, or you can also write 7 factorial as 7 into 6 into 5 into 4 into 3 into 2 into 1, that is equal to 5040, 5040. Now, find out the value of 7 factorial minus 5 factorial. So, what is 7 factorial? 5040 minus 120, that is nothing but 4920. Suppose if you want to find out the value of factorial 7 divided by factorial 5. Now, how to find the value of factorial 7 divided by factorial 5 can be written as, this is 7 into 6 into 5 factorial divided by, the denominator is 5 factorial gets cancelled. What is left is 7 into 6, 42. That is it. 7 into 6, that is equal to 42. This is how we are going to find the factorial value of any given number. So, factorial of n, so is in general n factorial is equal to n into n minus 1 into n minus 2 into n minus 3, etc. That's it. This is called the factorial notation. Now let us come to the next few examples. Compute 7 factorial by 5 factorial and 12 factorial divided by 10 factorial into 2 factorial. Now we have 7 factorial by 5 factorial. As I told, 7 factorial can be written as 7 into 6 into 5 factorial by 5. 5 factorials gets cancelled. 7 into 6 is 42. Similarly, 12 factorial divided by 10 factorial into 2 factorial. 12 factorial can be written as 12 into 11 into factorial 10 divided by 10 factorial into 12. So this 2, 10 factorial gets cancelled. What is left over is 2 6 are 12, 6 into 11 is equal to 66. Okay, these are all few simple problems to find the value of a given factorial. Now let us come to the next example. Evaluate n factorial divided by r factorial into n minus r factorial, where n is equal to 5 and r is equal to 2. This is very important type of problem. So this formula we are going to use in combinations and permutations. Now what is given? Given n factorial divided by r into r factorial into n minus r plus. Just replace n by 5 and r by 2 in the given equation. 5 factorial divided by r is 2 factorial divided by 5 minus 2 factorial. Since n is equal to 5 and r is equal to 2, therefore this can be written as 5 factorial divided by 2 factorial into 5 minus 2 is 3 factorial. So 5 factorial can be written as, that is factorial 5 divided by 2 factorial into 5 minus 2 factorial, factorial 5 divided by 2 factorial into 3 factorial. This is 5 into 4 into factorial 3 divided by 2 into 1 into factorial 3. These two gets cancelled. 2 2s gets cancelled. 5 into 2 is equal to 10. So this is equal to 10. 2 2s gets cancelled. 2 into 5 is equal to 10. This is how we are going to simplify this equation. So n factorial divided by r into n minus r factorial. Right. Now let us come to the formula for NPR. So the permutation of n different things taken r at a time is given by NPR is equal to n factorial divided by n minus r factorial, where r lies between 0 and 1. So in particular, if r is equal to n, then NPR is nothing but n factorial divided by 0 factorial. Since you know the factorial of 0 is always equal to 1. So 0 factorial is 1. So therefore n factorial divided by 1 is equal to n factorial we will get. Similarly, np0, np0 is also equal to 1, because n factorial divided by n minus 0 factorial is nothing but n factorial. N factorial by n factorial is equal to 1 we will get. So np0 is equal to 1. Now therefore the formula is applicable for r is equal to 0 also. This formula is also applicable whenever the value of r is 0. Thus NPR is equal to n factorial divided by n minus r factorial, where r lies between 0 and n. This is the formula which we are going to use to find the permutation of n different things taken r at a time. So in general, the permutation of n different things taken r at a time is given by NPR is equal to n factorial divided by n minus r factorial. This is the general formula for a permutation of n different things taken r at a time. So NPR is given by the permutation of n different things taken r at a time. So that is the arrangement of n different things taken r at a time is given by factorial of n divided by factorial of n minus r. So this can also be written like this, n factorial divided by n minus r factorial. That's it. Okay. Now let us come to the problems based on this. Find the number of permutation of the letters of the word Allahabad. So here there are how many objects, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters are there in the word Allahabad. Here we have 9 letters. Here 9 letters, here the objects are 9, that is 9 letters are there, out of which how many A's are there? So there are 4 A, 1, 2, 3, 4 A's are there and 2 L, and the rest are all each one are all different. So there are 4 A's and 2 L's and each one are all different. So therefore the required number of arrangement, how many letters are there? 9. That is factorial n divided by how many A are there? So 4 into factorial L is 2 into the remaining is 1 factorial. So therefore the arrangement is 9 factorial divided by 4 factorial into 2 factorial. 9 factorial can be written as 9 into 8 into 7 into 6 into 5 into factorial 4 divided by 4 factorial into t into 1. 4 factorial gets cancelled, 2 3s gets cancelled. What is left over is 9 into 8 into 7 into 3 into 5. So that is equal to 7560, 60. See, 2 3s gets cancelled. So that is 5 into 3 into 7 into 8 into 9 is 7560. This is the permutation of letters of the word Allahabad. Okay. Now let us come to the next example. Example 2. How many 4-digit numbers? How many 4-digit number can be formed by using the digits 1 to 9 if the repetition of digit is not allowed? In the previous problem there is no any conditions. So here what is the condition? Repetition of digits is not allowed. So how many 4-digit number? How many 4-digit number? So 1, 2, 3, a 4-digit number can be formed using the digits 1 to 9 if the repetition of the digits is not allowed. Now let us see how many digits are there. Here order matters. For example 1, 2, 3, 4, or we can also write 1, 3, 2, 4 because repetition is not allowed. There should not be any repetition. The order is of the form 1, 2, 3, 4 or 1, 3, 2, 4 are two different numbers. Therefore, we may say we will have 4 digits number as there are permutations of 9 different taken at 4 times. So here the order matters, like the order. Here the order of the numbers must be of the form 1, 2, 3, 4 or 3, 2, 4, 1 or 1, 3, 2, 4 because the repetition is not allowed. So the two different numbers. Therefore there will be many 4-digit numbers as there are permutations of 9 different things taken 4 at a time. So therefore the required 4-digit numbers, the arrangement of 9 different numbers taken 4 at a time is given by 9p4. That is 9p4. 9p4 can be written as, what is the formula for NPR? Factorial n divided by factorial n minus r. That is nothing but factorial 9 divided by factorial 9 minus 4. Factorial 9 divided by 9 minus 4, that is nothing but 9 divided by 5 factorial. This can be written as 9 factorial divided by 5 factorial is 9 into 8 into 7 into 6 into factorial 5 divided by 5 factorial. These two gets cancelled. 9 into 8 into 7 into 6 is 3024. 3024. So the number of 4-digit numbers can be formed from 1 to 9 is 3023. 3024. This is the best example. This is a small example to find the permutation of 4-digit number from 1 to 9. Right, without repetitions. Now let us come to the next problem. Problem 3, example, how many numbers lying between 100 to 1000 can be found with the digits 0, 1, 2, 3, 4, 5 if the repetition of the digits is not allowed? Again, if the repetition is not allowed, how many numbers lies between 100 to 1000 can be formed with the digits 0, 1, 2, 3, 4 and 5 if the repetition of the digits is not allowed. Here also, every number between 100 to 1000 is a 3-digit number. The first number will be say 101 and the last number will be 999. So all the numbers between 100 and 1000 will be a 3-digit number. It's a 3-digit number. We first count the permutation of 6 digits. How many digits are there? 1, 2, 3, 4, 5, 6 digits. So these 6 digits taken 3 at a time. So first find out the count the permutation of 6 digits taken 3 at a time. This number will be 6p3. This is 6p3. So but the permutation will include those also where 0 is at the 100 place. So for example, this is 092, 042, etc. So etc. are such numbers which are actually 2-digit numbers, and hence the number of such numbers has to be subtracted from 6p3, right? So to get the required number, to get the number of such permutations, we fix 0 at the 100 place and rearrange the remaining 5 digits taking 2 at a time. This will be 5p2. So in total, in general, the required number of permutation is 6p3 minus 5p2. 6p3 minus 5p2, that is equal to 6p3 minus 5p2 can be written as 6 factorial by 3 factorial minus 5 factorial divided by 3 factorial. So this is equal to 6 into 5 into 4 into factorial 3 divided by 3 factorial minus 5 into 4 into factorial 3 divided by 3 factorial. These two gets cancelled. 6 into 5 into 4 minus 5 into 4. So that's equal to 5 into 4, 20 into 6, 120 minus 5 fours are 20, that's equal to 100. So therefore the required number is 100. The required permutation is 100. That's all. Very simple concept here. Just since there are 6 digits are there, 0 to 1, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 digits are there. So we have to arrange the digits from 100 to 1000. So this can be done in 6p3 minus, since the repetition is not allowed, so therefore 5p2 minus 5p2 will give the value of this required permutation. So that's equal to 100. So that's all regarding this problem, right? Now let us know regarding the circular permutations. What is circular permutation? Circular permutations, right? The arrangement of n objects in a circle is called as a circular permutation. Arrangement of n objects in a circle is called the circular permutation. Now, the number of circular permutation of n objects, the number of circular permutation of n objects is always equal to n minus 1 factorial. So, the number of circular arrangement of n objects is n minus 1 factorial. Now, let us consider an example. In how many ways 5 persons can be seated at a round table, This is the question. Let us consider this example for circular permutation. So, the circular permutation of n objects is n minus 1. Here how many objects are there? 5 objects are there. In how many ways 5 persons can seated around a table? So that is nothing but since it is 5 objects are there, this can be done in 5 minus 1 factorial. That's equal to 4 factorial. That is 4 into 3 into 2 into 1. 4 is a 12, 12 to is a 24 ways. In 24 ways we can arrange. So 5 persons can be seated around a table in 24 ways. That's it. This is called the circular permutations. Okay. Suppose if there are 6 persons, the permutation around this round table is 6 minus 1 factorial is 5 factorial, that's equal to 120. That's it. Oh, this is how we are going to solve the problems on circular permutation. So these are the few basic concepts regarding the factorial notation and the problems. and few small examples on permutation. So, right, that's all regarding this session. Let us meet with a different concept in the next session. Thank you very much.